Okay, this is final exam review number 4. It talks about roots, zeros, factors, synthetic division. We'll get into the ins and outs of how to do all those as we get to the problems. So let's look at number 1. For the equation x cubed minus 13x plus 12 equals 0, 3 is a root. What are the other two roots? Well, let's graph it. So we got x cubed minus 13x plus 12. And you can see that it crosses the x-axis at -4, 1, and 3. So I would just graph that. And you can see it crosses the x-axis at -4, 1, and 3. Since we already given 3, it's -4 and 1 are going to be the other two roots. So just graph it and find them from there. Number 2 is using your answer choices to see which one gives you the zeros of 2, -3, and 1. So we'll graph each of the polynomials and see which one gives us those zeros. So we have x cubed minus 5x squared minus 2x squared minus 6. You can see this only gives us 1 0 at 7.118, so it's not going to be there. So let's look at letter C, I guess. We'll go for C. This has 3 zeros, -3, 1, and 2. So -3, 1, and 2 are your zeros. And if you see how that crosses the graph, that's our answer. So we got lucky on that one. Question 3, the volume of a rectangular prism is presented by the expression x cubed minus 2x squared minus 20x minus 24. If the length is x minus 6 and the height and the width are equal, what's the width? Volume is length times width times height. So what we can do on this problem is we can graph that and get the zeros. See, what these are factors. So this is one factor. So watch what happens when I graph the original expression. It's going to cross the x-axis at -2 and 6. So let's analyze this for a second. It hits -2, comes back down, then hits 6. This is a double root. So that factor actually gets counted twice because this is a cubic. So it's going to have 3 zeros, but this is a double root, so that 0 counts twice. So its factors are going to be x plus 2. Remember, we switched the signs for the factors. And then we have x plus 2 again. And then this factor at 6, this 0 at 6 is going to give you a 0, x minus 6. So if you multiply all 3 of these together, that would be, if the length is going to be your x minus 6, then the width and the height, which are equal, are both going to be x plus 2. And we can verify if we put x plus 2, if we type that twice, you can see it crosses there at -2, and then x minus 6 overlaps it, and it gives you the same graph. See how the red and the blue change? It's the same graph. So your width and your height are x plus 2. Number 4, the volume of a rectangular prism is represented by the expression x cubed plus 4x squared minus 11x minus 30. We're going to do the same type of work. So we have x to the 3rd power plus 4x squared minus 11x minus 30. We're going to get our zeros again. In this case, we got -5, -2, and 3. So your zeros are -5, -2, and 3, which means your factors are going to be x plus 5, x plus 2, and x minus 3. So remember, your factors and zeros are opposite signs. If the length is x plus 2, so this is your length, which of the following could be the expression of the width? So I don't know which one is the width or the height, but I do know that the only one of these two represented here is x minus 3, right? So this could be your width, this could be your height, and since we don't have x plus 5 available, then it's going to be the x minus 3. And question number 5. Suppose f of x equals x squared plus 5x plus k. The remainder of the division by f of x equals x minus 1 is 8. What's the remainder of the division by f of x equals x plus 3? So I use the remainder theorem. So I know that if I plug in 1, my remainder is going to be 8. So in other words, if I plug in 1 into x squared plus 5x plus some number k, I get 8. Now what I'll do is I'll plug in 1 here, and I'll adjust k so it gives me an output of 8. So if I move k to 2, look at my value is 8. So I can say plus 2 equals 8. So my remainder theorem says k is going to be 2. We'll verify that by hand, but basically 1 squared plus 5 times 1 plus k equals 8. 1 plus 5 is 7. 1 plus 5 is 6. 1 squared plus 5 times 1 is 6. So 6 plus k equals 8. And k is going to be 2. Now that we have the value of k, we can do another remainder problem. So now I want to plug in -3. So I'm going to say -3 squared plus 5 times -3. And now that I have k, I can say plus 2. And we can figure out what that remainder is. And you get -4. You can do this with synthetic division as well, but I find that that's a little bit more time consuming. So that's how I'll do it here. Number 6, this is the last one on the synthetic division. This is very similar to the last one. Why don't we do this one using synthetic division so you can see how it differs. So in this case here, what you'll do is you'll plug in -1 and you do your coefficients. So it's going to be -1 in the box. Your coefficients are 1, -2, 13, and our unknown. But we know the remainder is 8, -8. So remember, synthetic division, you bring down the first number, you multiply it, you add, multiply, add, multiply, and then you solve this last one, k minus 16, or k plus -16, which is minus 16 equals -8. You can add 16 to both sides, and k is going to give you 8. But now we have to do it one more time again. So knowing that my k value is 8, I will go back and do another synthetic division with +1. And plug that 8 back in. 1 times 1 is 1. Add those together, you get -1. -1 times 1 is -1. Add those together, you get 12. 12 times 1 is 12. And then 12 plus 8 is 20. So your new remainder is 20. So you can do that with the remainder theorem or with synthetic division like we just did. Part 2 goes over the long division process. You can read through that on your own. What is the remainder when you divide these two values in using long division? So let's go over the long division process. When you're doing long division, you want to insert any missing terms. So there's no x term, so we'll put a 0x there. You have to see how many times x squared goes into x cubed. So x squared times x gives you x cubed. Multiply that by these three outside. So x times x squared is x cubed. X times negative 2x, that's going to be negative 2x squared. X times 1 is x. Subtract, so we're going to have to change all the signs. Remember, when we're changing the signs, that's going to make the minuses plus and the pluses minus. So it's going to be canceling those out. And that's negative 6 plus 2, negative 4x squared. 0 minus x is negative 1x. And then bring down the minus 12. Next, we see how many times x squared goes into negative 4x squared, and that'll be minus 4. We do another distributing, so negative 4 times x squared is negative 4x squared. Negative 4 times negative 2x is positive 8x. Negative 4 times 1 is negative 4. We want to subtract, and we're going to subtract going down, which means we're going to add that 4, add that negative 4. And so you're left with negative 1x plus 8 minus 8x, which is negative 9x. Negative 12 plus 4 is negative 8. So your answer is x minus 4 plus negative 9x minus 8 over x squared minus 2x plus 1. Now the question says, what's the remainder? The remainder is the negative 9x minus 8. All right, you can do long division also. You can kind of cheat using graph matching if it gives you the whole expression. So you could do number 2, for instance. You could say 6x cubed plus 8x minus 10 divided by 2x minus 2. And then you could go through and you could test each of these answer choices in a graph and see which one matches up. So we could graph this and see which graphs match. And that's the method I'm going to use here. And you can double check that using long division by hand. So look at these graphs. Neither of them overlap. So I'm going to go ahead and get rid of those. Let's look at the last two. We'll say 3x plus 7 plus 4 over 2x minus 2. And then we have 3x squared plus 3x plus 7 plus 4 over 2x minus 2. So it looks like this graph here is the same one. You see how that matches up? This one's way off, but it's definitely going to be this one here. So we got away without having to actually do long division on that. All right, number 3. Simplify the following expression. We have, this is a rational function. We can simplify this by factoring and canceling out. So I'll start with getting the GCF. You can pull out a 2x here. That's going to be x squared plus 6x plus 9. I'm going to pull out a 4 here, so that's going to be 4 parentheses x squared minus 9. And then we have to factor that more, so that's going to be 2x parentheses. What multiplies to 9 and adds to 6? It's It's going to be x plus 3, x plus 3. And then down here we have a difference of squares, so that's going to be x plus 3, x minus 3. And then we'll go through and simplify. So we can cancel out the x plus 3's. And we can also cancel out the 2, and that reduces that to 1/2. So it's going to be x over 2, x plus 3 over x minus 3. Now I want you to, on these graphs, always check your original and your simplified expression. So you can go through and press the fraction bar first. You do 2x cubed plus 12x squared plus 18x, and do that over 4x squared minus 36. And look at that graph, and then test all your answer choices out. And once you get to the one that matches the graph up, you are good. See how those are the same. We can do that with any of these. So in division here, I'll go through that by hand. This is x minus 3, x plus 7. You can verify that. This is x plus 3, x plus 5. And when you're simplifying that, we have x plus 7 over x minus 3, x plus 7. And instead of saying divided by, we multiply, we do the keep, change, flip. So we multiply by its reciprocal. So we do x plus 3, x plus 5 over x plus 5. Now if we do some canceling, those will cancel. And so will those. So all we have left is x plus 3 on the top of this fraction and x minus 3. So on the bottom, so that's going to actually simplify to x plus 3 over x minus 3. And let's check that with the graph. So when you're doing division, what you'll want to do is you do a division bar first. That's going to be your first slash. And then you do a fraction bar on top. So you do x plus 7 over x squared plus 4x minus 21. Then on the bottom, you do another slash. You do x plus 5 over x squared plus 8x plus 15. And you see your graph, and then we know that the answer is x plus 3 over x minus 3. Same thing, so those match up. And we can do that here too. So try to factor these and see if you can cancel out, but don't worry so much about if you can do what we did here on the graph, you can get away with getting your answer that way as well. So this is going to factor as a difference of squares, x plus 2, x minus 2. This is x plus 3, x plus 3. This is x plus 2, x plus 2. And then this is x plus 3, x minus 3. So again, we can do another keep, change, flip. So KCF. So we'll do x plus 2, x plus 2, x minus 2, x plus 3, multiplied by the reciprocal, and just start canceling. All right, you got x plus 2's, those cancel out. You got an pair of x plus 3's. One of those cancels out on the bottom, and you have an x plus 2, x minus 3. Excuse me, x minus 2, x minus 3, x plus 3, x plus 2. And so that's going to give us, looks like this one here. These are the restrictions. These are just the numbers you can't plug in. But when you're graphing that, you can verify the original in this expression here, which I'm not going to do in this video. Finally, for part 3, our last part on this review, this is a longer one. We want to simplify and state the restrictions. So we have some more here we're going to go through and do, adding, subtracting, So simplifying and stating restrictions. With these ones, you have factor them. It's going to be x plus 5, x plus 1. So we have to match our denominators. So we're going to need an x plus 1 on the top and the bottom. And so that's going to be x minus 1 over x plus 5, x plus 1, minus x plus 1 over x plus 5, x plus 1. And the numerators get combined, so that's going to be x minus 1 minus, that's going to be x squared. And then minus x times 1 is minus x. And the x's will cancel out. So you're going to get negative x squared minus 1 over x plus 5, x plus 1. Turns out that you can factor out a negative 1 there. So that's going to be negative 1 x squared plus 1. But we don't need to do that, so we can leave it like B. Again, verify that in a graph if you wish. You just do x minus 1 over x squared plus 6x plus 5 minus x over x plus 5. And then you can go back and look at your answer choice for letter B, fraction bar negative x squared minus 1 over x plus 5, x plus 1. And again, they overlap each other, so those are the same. So let's talk about solving. To be honest with you guys, these require a lot of hand steps, so I'm going to solve using the graph. Always put each side into your y and find where the graphs intersect. So we'll do the first one, 30 over x squared minus 9 plus 1. And you do 5 over x minus 3. And it says, what's the set of the solutions? So we have options. We can see where they cross here. And it looks like they cross at 2. But only 2. They don't cross at 3. So if you did the line x equals 3, you can see that's actually a vertical asymptote. So neither of those graphs touch 3. So x equals 2 is going to be your solution. Go down here and do the same thing for number 3. You do x over x minus 3 plus 4 over x. And then you do fraction bar x plus 3 down x minus 3. And negative 12, 12, 3, and 4. Looks like these guys cross here at 12. You can just click on that intersection. They cross at 12. And do the same thing for 4. Looks like these cross at 2.8. So that's a positive value. So one of those is 2.8, 14 divided by 9, or 14 divided by 5. And as you can see, 2.8 is 14 divided by 5. So they cross at 2.8, which is 14 over 5. Again, just want the x values when you're doing these. I got one more here. So let's do that with the last one. Do the whole left side of this in y, and then the right side in y as well. So 2 over x plus 2 plus 3 over x squared plus 5x plus 6. There's that graph. And then we have 1 over x plus 3. And looks like they cross here at -7. -7. So there you have it. You can do equations by graph intersections to get this one here. Thanks for watching.